gold tin. Which composition close to the ratio close to this, right? Gold is iron, replace iron, tin is this one, right? So I will use gold. Okay? Wyckoff number, you see? Wyckoff number. 2D. Tin, 6H. So yellow means we need to key in the value. So we just need to key in this value. 0.150.769. No, nothing. Software will auto. Okay? So Y no need to key, Z no need to key. Software can calculate for the automatically.
Always like that, always.
No, only yellow one you need to key.
Oh, depend.
Depend on crystal. When number changes, actually the 194 means we must key in this. Right? If you change it to maybe 1, you key more, right? The group, space group. So here you also can change the color. So gold, cancel. So next I will put pink. Pink.
Oh, because they are two separate.
So later you will understand. Two atom pink. Okay. Maybe I give the color of green. Okay. So I also need to put Wyckoff number to D. So however, if I change it to D, software no need to ask me to put in anything. It's already set up. So now what I need to do, I need to save. Save. I will put it on the desk. Training document. Training document. Where's my training? D. Document. DBSD. Okay. Save. So if the software has created this thing, we can check the you can see this is a hexagonal crystal we have set up. Cubic is another way to describe this data. You see, cubic is described like this. See cubic? So diffraction is created by this one. For example, we also can show PPG pattern like this. Even more crystals. So anyway, the smallest unit cell for this system is like this. And then this software can simulate some orientations. The Euler angle is high. Okay? So this is our software. We can create a CRY file. Okay? So also this can create the diffraction data. So diffraction data similar to XRD will give you plan, spacing of two lengths, intensity. You also can find it. But they should be very similar. But spacing may be similar, but diffraction should be similar. No. You can check. They are similar, right? because we need this to create the Kikuchi pattern. Kikuchi pattern is also this one, right? By showing in the 3D space, right? Okay, so we have created. So we go to Extract Crystal, create. Okay, it is better if you can download a CLF file from internet. But if you cannot, you can create CLY.
CLY.
I choose. So this is I have set up here. What we need to know is KV.
KV.
So the simulation, the KV used for simulation is what do you set?
59.
Okay. Then we can start our simulation. So software will save our simulated pattern with a new format. Software just asks you where to save. Okay. Save this way. So the problem is so when we do simulate pattern, sometimes dynamic simulation is long, depending on the crystal structure. It's also depending on the PC. But this PC normally is good, so it can be fast. But if you do others, you can find our video.
The step, indexing.
Yeah. But because if you do this, sometimes you feel confused. You don't know what to do. So just follow the Okay, so the crystal structure is created. So we need to add this file. Then simulation patterns. R value is gone. So normally, as I said, R value should be higher. Higher is better. So this value actually is small, is not good. So we index, you can see the R value is improved. Okay? Index 2, yeah. Higher is better. So you can see how they calculate R value, compare the difference.
Okay.
Yeah.
Hey, the dark color place cannot be.
Black,
Uh-huh.
no data. Okay.
Or if let's say the black
White
area.
black, no data. Even some black area, we have orange pattern, but still cannot find this. Why? Because the pattern created based on the crystal structure we set up, but the pattern is calculated from the initial orientation. This one. This initial orientation actually is coming from here. It's detected by EBT during the mapping. So we put this data into the crystal structure, then we get this. Now we compare them and we get our value. Right? So what we need to do for indexing means we try to, we try to find the simulated pattern, which may be close to this one. But we don't know this, how we create, how we find this value. So software is very interesting. At this point, software will create a dictionary. Basic, one orientation, one pattern. Then compare with the created dictionary. If we find, we will use the highest R as the pattern, the simulated pattern with the highest R as the solution. Then this value is getting, right? But when we do refine, actually we only can check the result already.